we have come to the concluding section or session of Unit 5, Session 6. We're going to look at some properties of variance. Some properties of variance. Just as we consider the variance, we're going to look at some properties of it. So by the end of this session, we should be able to calculate the variance of some functions of a random variable. Yes. Now let's consider some theorem. Just as we did for the expectation, we're going to look for that of the variance also. Theorem 1. If a greater than 0 is a constant, then the variance of a equal to 0. So in a simple sentence, the variance of a constant is 0. Remember, unlike the expectation, the expectation of a constant is the constant. But here the variance of a constant is 0. It could be proven if you want the proof. Or you can check in your models for that proof. Theorem 2. Suppose that a is a constant and x is a random variable, then the variance of ax will be equal to a squared multiplying the variance of x. A squared multiplying the variance of x. In another way, if you have to find the variance of 3x, then that will be 3 squared multiplying the variance of just x. And that's what it means. That's what the second theorem is saying about. Now look at the theorem 3. Suppose we have a and b, they being a constant, and x is a random variable. Then the variance of a, the expression ax plus b, will be equal to ax squared multiplying the variance x plus 0. Do you know why we say it's plus 0? Because the last variable, that's b, is a constant, and the variance of a constant is 0. Yes, the variance of a constant is 0. Good. So if you understand that, then let's pick up some example. Let x be a random variable with a PDF. F of x equal to 3x squared over the interval 0 to 1, or 0 all squared. We have to calculate the variance of x, and the b part of the question says if the random variable y is defined by y equal to 3x minus 2, we have to calculate the variance of y. So first of all, the question is in twofold. We have an a part and a b part. Look, given the function there, 3x squared, the interval 0 to 1. Calculate the variance of x. So look at that. Solution. So the variance of x, first of all, we need to find the expectation of x. That's integrating the function multiplied by x over the interval that's 0 to 1. And doing everything diligently will give us 3 over 4. Of course, remember this example? You can cross-check with the previous sessions. I think session 4. That gives us 3 over 4. Or better still, 0.75. And also finding the expectation of x squared. That will give us 3 over 5. That gives us 0.60. So to find the variance will now be 0.60 minus 0.75 squared. That gives us 0.037 as the correct answer. Yeah, quite very simple, right? Yeah, I guess so. But now look at the B part of the question. That we are giving a y as an expression in terms of x. Now look at that. So we get y is equal to 3x minus 2. We have to find the variance of y. So what does it mean that variance of y will be equal to variance of 3x minus 2? Then the variance will now be equal to 3 squared multiplying the variance of x minus the variance of 2. And that variance of 2 is a constant, so it should be equal to 0. And remember that the 3 squared is 9, and the variance of x, as you had in the previous example, is 0.037. And doing the algebra, We should arrive at this answer as 0.3375. That's very wonderful. So, at the end of this session, and the end of the unit, at the unit 5, you were able to consider numeric characteristics of a random variable, right? By finding the expectation and also the variance for both discrete and a continuous random variable. Thank you very much. Now look forward to the concluding unit, that will be the unit 6 for this module.